All right, question 2 says, fill in the blank. The exponential equation y equals b to the x is equivalent to the logarithmic equation blank. All right, so as we've seen, to go from an exponential statement like y equals b to the x, the logarithm is equal to this exponent here, which is x. So we have that x is equal to the logarithm. Now the base of the logarithm will be the base of this exponential expression, so that'd be b. And then the thing that goes in the log is just the value of the exponential expression, which is y. And so we see that the exponential statement y equals b to the x is equivalent to the logarithmic statement that x is equal to log base b of y. And if I'm thinking input-output here, x being the input and y is the output, notice that by converting to the logarithmic statement, I'm now saying that the input x is equal to the log base b of the output. Okay, so this relates back to something that we saw back in section 13.3 when we looked at inverse functions. Okay, so remember we did problems like find the inverse of this exponential function f of x equals 2 to the x. Well, to do that, what we said was, well, for our function f, the relationship between the output y and the input x is y equals 2 to the x. So then for the inverse, we just swap the roles of input and output. So we would get that x is equal to 2 to the y. And so now, how do I go about solving this equation for y? Well, I convert from this exponential statement to the logarithmic statement. See, this exponent y will equal the log, and this would be base 2, because that's the base of this exponential expression, of x. And then we would write our final answer in function notation. F inverse of x is log base 2 of x. Okay, so now that we've actually filled out more details about how logarithms really work, this starts to make a lot more sense. Okay, so we're saying that for an exponential function like this, f of x equals 2 to the x, its inverse is the logarithm. Okay, great, we'll stop there.